Hello, welcome back. Hope y'all had a great break, and we gotta jump right in because we are cruising through the spring semester, and we'll be taking our test soon. So we have several things to get covered before we do that. Tonight we're going to be talking about surface area. So today in class, when we looked at the net of different shapes, and we were able to figure out the volume of shapes by a net. We learned what a net is, not a net, like the name of a lady, but a net is. So today we're going to be talking about the difference between surface area and lateral area of geometrical shapes. And don't worry, there's a finish line for this geometry shape, the shape part. We are going to look at those nets again tomorrow, and then we're going to do a little review activity and then a quiz on Thursday. And then we'll start a new unit on angles, angle measurement on Friday. So that's kind of where we're headed. So I want to tell you about surface area. So there's two types of surface area. There's a lateral surface area, and there is total surface area, and I'm just going to abbreviate it SA. Okay, there's lateral and total surface area. So the lateral surface area, okay, here's what lateral surface area is. It's the area of all sides of an object except, just a big thing here, except the bases. So top and bottom. So it's just the sides, okay? It's not the top and the bottom. All right? So remember, area is two-dimensional. Two-dimensional. Length times width. Remember, area of a circle. Pi r squared. Okay. Area of a circle. So, length times width, pi r squared. Just two-dimensional. There's no big B, little b, whatever. It's just a two-dimensional thing. So, like we looked at today, the nets where we were able to stretch them out and make it flat, and you could see the net, kind of the footprint it leaves. Well, that's kind of what surface area is where you were to take, if you were to have a cylinder, you would just unwrap it, and it would just be a big rectangle that wraps around the whole side. And it's not the inside of the cylinder, it's not that stuff in the middle, that's volume. It's just the it's just going to be the area of the outside, okay? So if I have a Coke Zero here, okay? So the surface area of my Coke Zero would just be the black part, okay? It would just be the outside. It would not be the area of the top, so you wouldn't actually take the area of a circle or the area of the bottom circle. It would just be the surface, the area of the sides. So if I were to cut this, if it was empty, and I cut it open, and I stretched it and flattened it out, you could tell that this would be just a big rectangle, okay? Just wraps around this Coke. All right, so that's lateral surface area. Now, total surface area is the area, so it's still area, so it's still two-dimensional, area of all sides, including the bases. Okay, remember, it's not the volume, it's not the filling in the middle of the three-dimensional shape, it's just the outside on the top and the bottom. So the total surface area of this Coke would be the area of all of the outside, the black part, it says Coke, the area of the top, and the area of the bottom. Okay, that's the total surface area. It includes the bases. So remember, area, again, is two-dimensional. Alright? So your units would be in something squared. Alright? So let's do an example with a cylinder, since that's what I just used here. I'm going to draw my cylinder here in the middle. Okay, there's my cylinder. And it has a radius of 3 inches. Okay, 3 inches. And a height of 7 inches. This is the height. 7 inches. Okay. So, let's look at lateral surface area first. So the lateral surface area, since it's a circle, even though when you unwrap it, it becomes a rectangle, we know, like when you unwrap it, it would be like this, right? We know this part is 7, right here, because that's the height of it. We don't know what this measurement is up here. And so the only thing we know is that it wraps around and makes a circle, so we still have to use a circle formula there. And the lateral surface area formula of a circle is going to be 2 pi times the radius times the height. Okay? 2 pi, radius, height. Alright, so on this example, we don't need to use calculators here because this is going to be something that you could see on your STAR test. 2 times pi, we're going to use 3.14 as the pi, times the radius, which is 3, right here, times the height, which is 7. So I'm going to go ahead and do 3 times 7 is 21, times 2 is 42. So 42 times 3.14. Remember, with multiplication, it doesn't matter what order you multiply them in. You could do it any way and you would get the same answer. And then if we did 42 times 3.14, okay, 42 times 3.14, save your time and mind. You could do that by hand, which you will be able to do in class. It's $131.88, okay? And that's going to be inches squared, okay? So this is a area, so it's a square unit. So that's going to be our lateral area, just that side, okay? So now, to get the total surface area, we're going to take that 138, so this is our lateral area, forming 131.88 inches squared. And we're going to add to that the area of the top, which is a circle, and the bottom, which is a circle. So if we remember, our pi r squared is, so we're going to add that to this next formula. Pi r squared is our area of a circle, but we have 2 of them. So we're just going to put 2 in front of it, pi r squared. Okay? So the 2 is because there's a top and a bottom. There's 2 of them. So now this is going to be your, this is the area of the bases. 2 times pi, so I'm going to put that here, area of 2 bases. Okay. So it's 2 times pi times r squared. Well, let's see what that is. You have 2 times 3.14 times the radius, which was 3 times the radius again. That's radius squared. So we have 9 times 2 is 18 times 3.14. Okay? And that is .52. Okay? Alright, so that we have to add this to this, remember? Because this is the area of the the top and the bottom bases. Then we need to add that back to the area of the lateral area, which was that just the black part of our coat. Okay? So 131.88 plus 56.52 It's going to be 188.4 inches, and it's still cubed because it's still, squared, because it is area. Okay, so sorry if you can't see that. I'm going to zoom in there. 188.4 inches squared. And that's how we get the total surface area. So that we could do that for any shape. We could do that for pyramids. We could do that for rectangles, prisms, anything. We could take the lateral and total surface area, and we just do it like we did today in class. You have to imagine it being flattened out, and you would take all the area of the shapes. Okay? All right. Well, have a good night, and I'll see you tomorrow.